In the last sessions, we saw that serializability was a useful concept because it allows programmers to ignore issues related to concurrency when they code their transactions. Okay, so if every transaction has the property that it maintains database consistency if executed alone, then serializability ensures that concurrent executions also maintain their consistency. And this is done by the transaction monitor of the DBMS. Okay. The SQL standard also allows a transaction to specify that it may be executed in such a way that it becomes non-serializable with respect to other transactions. For example, a transaction may operate at the isolation level of a read uncommitted, okay, which permits the transaction to read a data item even if it was written by a transaction that has not been committed. We saw that this was not possible in Oracle because Oracle only read committed, okay? But SQL provides such features for the benefit of long transactions whose results do not really need to be very precise, okay? So let's have a look at how isolation can be implemented in various ways in a DBMS, okay? A policy in which only one transaction can execute at a time generates serial schedules, but provides a poor degree of concurrency. We saw this point earlier, okay? So that is a policy where a transaction TI acquires a lock on the database before starting a transaction and releases the lock only after committing or aborting the transaction, whatever, okay? But after the transaction completes. Such schedules are trivially serializable. And we do not really want such kind of schedules to run in the database because it leads to a very poor degree of concurrency. Okay. So concurrency control schemes basically have a trade-off between the amount of concurrency that they allow and the amount of overhead that they can incur. Okay. Now, there are 4 transaction isolation levels defined in terms of 3 phenomena, which we have seen in the last session. Okay, and these 3 phenomena must be prevented to some degree between concurrent transactions. So what are the phenomena that we looked at? We saw dirty reads, we saw non-repeatable reads, and we saw phantom reads. Okay, so what is a dirty read? Basically, a transaction reads data written by a concurrent uncommitted transaction. Okay, what is a non-repeatable read? A transaction rereads data that it has previously read and finds that the data has been modified by another transaction. And that transaction could have committed since the initial read. Okay. Phantom reads. A transaction re-executes a query returning a set of rows that satisfy a search condition and finds that the set of rows satisfying the condition has changed due to another recently committed transaction. Okay, so these are predicate-based transactions that we can look at. Okay, and they conflict on a phantom tuple. So these are the 3 cases that we saw, 3 anomalies which we saw in the last session. And the 4 transaction isolations try to handle these 3 phenomena in different ways. Okay, so let's look at what they are. Now, data manipulation languages must include some kind of a construct for specifying the set of actions that comprise a transaction. Okay, so we know that a transaction ends either with a commit or an abort. An abort which basically leads to a rollback of the work. Okay, so the levels of consistency or isolation levels specified by the SQL standard are basically 4. They are serializable, repeatable reads, read committed, and read uncommitted. Okay, so let's start with what they would actually mean. Serializable usually ensures serial execution. Okay, that is, it ensures serializability, which would force a transaction to wait for other transactions, or in some cases to abort, because the transaction can no longer be executed as a part of the serializable execution. Okay, so that's the point with serializability. It gives you a very much lower degree of concurrency in the execution. Okay. The next is a repeatable read, where only committed records can be read, and repeated reads of the same record must always return the same value. Okay. So repeatable reads allows only committed data to be read. Okay. And it further requires that between two reads of a data item by the same transaction, no other transaction is allowed to update that data value. Okay. Read committed, only committed records can be read, but successive reads of records may return different but committed values. Okay. In other words, read committed, although it allows only committed data to be read, it does not require repeatable reads. Okay. So we are as we go down the points that we're looking at, down the different isolation levels, we are increasing the degree of concurrency, but reducing the possibility of this phenomenon not occurring. Okay, so we will see that. Okay, and the last is read committed, where even uncommitted records may be read. Okay, it is the lowest isolation level allowed by SQL. So let's look at it via a chart. So if we have an isolation level where we have it as read uncommitted, then dirty reads are possible, non-repeatable reads are possible, and even phantom reads are possible. But we need to note that dirty reads are one of the worst possible things that can take place, that we don't want basically to happen, but it is allowed if we have read uncommitted. Okay. If we have read committed, dirty reads are not possible, but non-repeatable reads and phantom phenomena are possible. Okay. If we have the isolation level set to repeatable read, then obviously dirty reads are not possible, non-repeatable reads are not possible, but phantom reads may be possible. And if we have the isolation level as serializable, then none of these phenomena are possible. Okay. So as we go down this, the degree of concurrency reduces as we go down this. Okay. The degree of concurrency reduces, but the phenomena that take place increases. Okay. We prevent this phenomena from taking place. So what I'll repeat my statement again. As we go down this, the degree of concurrency reduces, and also the possibility of all these three phenomena taking place are removed. Okay. Now, all the isolation levels that we have just looked at additionally allow, I should say, additionally do not allow dirty reads. Okay, so I'm repeating that statement again. All the isolation levels that we have just looked at, the 4 isolation levels, do not allow dirty writes. Okay, that is, they disallow writes to a data item that is already written by another transaction that has not yet been committed or aborted. We saw what is a dirty write in the previous section. So none of these isolation levels allow you dirty writes. Okay. Many database systems run by default at the read committed isolation level. And we saw that that is what Oracle also does, right? So what Oracle basically does is, let me say that again. Oracle, when it gives you read, when you ask for read committed, it actually gives you read committed. And when you say repeatable read, it gives you read serializable. So basically, it has only 2 levels of isolation provided to you, read committed and serializable. And we'll see how this works and what is the meaning of this. Okay. So the actual implemented isolation levels in Oracle is stricter than what you have actually selected, but it only gives you 2 for selection. Okay. So SQL standards basically define what must not happen. So read uncommitted will not happen. Repeatable read will not happen when you ask for serializable. And when you ask for read committed, read uncommitted will not happen. Okay. Now, changing of the isolation level must be done as the first statement of a transaction. Okay. And obviously auto commit of that should be set off. Okay. So you, whenever we have the default auto commit on, that should be set off. And you can use the isolation level or change the isolation level of a transaction as the first statement in the set of transaction statements that you're going to be making. Okay. And how do you do it? You say set transaction isolation level to whatever is the isolation level that you want. Okay. So let's look at, and what we'll do over here is we will create two transactions executing. Okay. In two different setups. Okay. It's like we did in the last class. We can see these two transactions directly executing. What we will do over here now is we will set the transaction isolation level to read committed and for both these transactions and see how it gets changed. Okay. So set transaction isolation. Let's see what are the transaction isolation levels allowed for us. So there are two that is allowed to be set, serializable or read committed. So let's set it first to read. Sorry. Okay. And in this also, we will set it to read committed. Okay. Now, in the last class, actually, we saw the same things happen about 2 sessions ago. We saw something like this happening, but we didn't have to set the isolation level to read committed because we said the default level of Oracle is read committed. Okay. So now let's have a look at what happens to both these transactions and what is the view that they get of the data of the other transaction. Okay. So I will first clear the screen so that we focus only on that. I'll do the same thing here. Okay. Now, let's see what data is in there in the table first and foremost. I have a table called P, so I'm going to be using this. Okay. Let's see the same thing over here. Although I've just opened it, it is bound to give us no rows selected, but let's have a look. Okay. Okay. Now, in transaction T1, I'm going to call this transaction T1. Okay. In this window, I'll call it T1. I will insert into my table P. It's got only one row. If you want to see, we will describe that. But first, since I've inserted the statement, I'll continue with this. We'll just describe P. Okay. It's only got one attribute of type number, data type number. Okay. So the insert statement went and it said one row created. Okay. I will do the same thing over here. So insert into P. Okay. I'll put a value 2 here. Sorry. Okay. One row created. Now I'm going to select. I'm neither committed from either of these. So in this particular transaction, if I do a select statement, I should only get my value 1 shown to me. Okay. Correct? Because I have said read committed. So if T2 had inserted the value 2, it will not show to me in transaction T1 because I have not committed this in transaction T2. Okay. So over here, I will only get the value 2 shown to me. Sorry, I've done it twice. So I got it now twice. Okay. I'll do a select statement. I should get it shown to me twice. Okay. I have not committed anything. So transaction T1 didn't see 1 and T1 also didn't commit. So transaction T2 will not see the 1 inserted. Now I will commit here. Okay. Now when I commit here and I go back to this window, since T2 is committed, I will get 2 2s and 1 1 shown to me. 1 of transaction T1 and 2 2s of transaction T2 that was there in the T2 window. Okay. So this is what I will end up getting. Now, if I come back here and I select still, I will only get 2s because I have not committed transaction T1s first, right? So I will say commit now. Now this particular transaction is complete. And if I see it, I will get all the values that I want here. And even in this window, I will get all the values shown to me. Okay, now both of them reflect and show me the same thing. Okay. Now, this is what read committed does. So remember what we have done here and what happens only after we have committed the transaction and the transaction completes, will the other transaction get to see the updated or the committed values. Okay. Now what we will do, we will see what happens when we say serializable. Okay. Now remember, the moment I committed here, I got to see the updated value. Okay. Now let's see what happens when we go for a serializable mode. So I will clear the screen. Here, I will clear the screen also. And now I will set transaction isolation levels. Instead of read committed, I will set it to serializable. Okay, in both my windows. Okay. Okay, the same thing here. Okay, now we will do the same insertions that we had over here, but I'll insert the values 3 and 4 so that we don't get confused. Data is 1 and 2 are already there. Okay, so in this particular transaction, I will insert into the table value 3. Okay, then we come to this. Okay, let's see what updated value I get here. 1, 2, and 4 expected, right? Then we come to this. Okay. Commit. We come to this. Notice what has happened. Although I have committed this transaction here, I have 1, 3, 2, 2, and I have 1, 2, 2, 4, correct? But now the 3 has not been shown to me over here, although I have committed this transaction. Remember that we said serializable will give you, will not, will have that's repeatable reads should be there. So even if I read the entire thing n number of times, I will get the same thing over here, because the previous transactions data is not shown to me, because I want repeatable reads in my transaction over here since I have done it as serializable. Look at this also. Okay. Notice that 4 is not shown to me here. Correct? So when I commit and now I do a select over here, notice that the updates are shown to me because now I have committed. My transaction is complete. And the database, now the next read will show me what has been updated on the database. Okay. And now because I have committed there and I have committed this also, I will get all the values shown to me here. So notice the difference. Okay. Serializable, although it was read committed and the values were committed, okay, I didn't get to see the committed values until my transaction also completed. Okay, so that's the difference between serializable and read committed. Okay, so if you want to see it on slide, this is what tends to happen. So read committed is a default isolation level. When a transaction runs on this level, a select query sees only the data committed before the query began. It never sees either uncommitted data or changes made by concurrent transactions. The same thing would happen over here. Okay. In read committed, the select query does see the effects of previous updates executed within its own transaction, even if they are not yet committed. It's its own transaction, it sees updates, and we saw that. Two successive select commands can see different data because some other transaction may have committed the value, right? So once the other transaction committed a value, the first transaction could see the committed values updates. Okay, so two successive select commands can see different data even though they are within a single transaction if other transactions commit changes during execution of the first select. Okay, whereas this is not the case for a serializable. It is the strictest isolation level. Applications using this level must be prepared to retry transactions due to serialization failures. Okay, so when a transaction runs in this level, a select query sees only the data committed before the query began. It never sees either uncommitted data or changes made by concurrent transactions. So remember this, it does not see changes made by concurrent transactions. We saw that even if the commit was there and commit had been done, this is not allowed. So that's the statement. The select query does see the effects of previous updates executed within its own transactions, even if they are not yet committed, because it is within its own transaction, right? Different from read committed in that the select sees a snapshot as the start of the transaction, not as the start of the current query within the transaction. So until the transaction commits completely, right, we did not get to see the updates of the previous transaction, even though the transaction had committed. Okay, so this is what happened. That's why two successive select commands within a single transaction always sees the same data. So if we go to this slide of ours that had this, in serializable, non-repeatable reads were not possible. We do not see phantom phenomena. It's fine. That's okay. But you will know that there is a difference between the two. Okay. So we will look at concurrent schemes in the next session.